Lesson number 15, Controlling the Quality of Parts. After producing a few sample parts from your setup, check each part for proper dimensions against the part print. Check the overall part length and some of the major shank lengths. The major shank lengths are the shank lengths that are controlled by the feed attachment micrometer stop. These are the first feed out of the first feed cam and the first feed out of the second feed cam. Also check some of the radii. The difference between these first few parts and the part tolerances will give you an overall idea of how the setup is producing parts. If only one feed cam is used, first check the overall part length. Decide if the overall length must be increased or decreased and by how much. The length of the overall part will be adjusted by changing only the length of the first feed out of the first feed cam. If the part length must be increased, turn the feed attachment micrometer stop to the desired amount to correct the length. This will allow the feed lever to return farther in its cycle. This will mean that the first feed cam follower will contact the first feed out of the first feed cam earlier in its cycle. The feed rolls will rotate more during the first feed out, increasing the feed out length and the overall part length. Notice that the overall part length has increased, but only the dimension of the first feed shank has changed. If the overall part length must be decreased, turn the micrometer stop the desired amount to correct the length. This will shorten the feed attachment return. This will cause the first feed cam follower to come in contact with the first feed out of the first feed cam later in its cycle. The feed rolls will rotate less during the first feed out. Their overall part length and the length of the first feed out shank will be shortened. Only the dimension of the first feed out has changed. All other feed out lengths of the part being produced are fixed by the rises cut into the cam. Lengths and positions of shanks in the body of the part can be adjusted by moving the tool axial position. If two feed cams are used, the second feed cam follower micrometer can also be used to adjust the overall part length and the shank length within the body of the part. Turning the second feed cam follower micrometer adjusts the length of the first feed out of the second feed cam. If the overall part length is too short because the first feed out of the second feed cam is short, turn the micrometer stop to increase the length. This will cause the second feed cam follower to contact the first feed out of the second feed cam earlier in its cycle. This will lengthen the part. Notice the overall length of the part has changed, but only the dimension of the first feed out of the second feed cam has changed. If the overall part length of the part is too long because the first feed out of the second feed cam is too long, turn the micrometer to shorten the part lengths. This will cause the second feed cam follower to contact the second feed cam first feed out later in its cycle. This will shorten the first feed out. The overall part length has been shortened. Only the dimension of the first feed out of the second feed cam has changed. With the overall part length correct, check the part for proper shank lengths. Shank lengths and the position of the shanks are controlled by moving the tool axial position. Also tool width and a combination of tool width and stock feed out will determine the shank lengths. Moving the tool axial position toward the bushing will shorten the length of the shank between the tool and the bushing, while it will lengthen the shank toward the collet. Moving the tool axial position away from the bushing will have the opposite effect on the workpiece. Whenever the tool's axial position is moved, the clearance between the tools and the bushing should be checked and reset if necessary. The cutoff tool should be 2 to 4 thousandths from the bushing. If the part is to be knurled, the knurl tool actual position must also be set. Set the knurl tool actual position after the shank to be knurled is properly positioned on the part. Start the machine. Allow the machine to run to high point of the knurl cam. Stop the machine. Adjust the knurl tool actual position to align with the proper shank. With the tool actual position set, the cutting tool radial adjustments can be made. If the tool radial adjustments are more than 5 to 7 thousandths off, the tool safe distance must be reset before the tool micrometer radius adjustment can be made. You may have to compensate for tool movement when setting the tool safe distance with the distance gauge. With the tool cams at 0, turn the tool micrometer radius adjustment in the direction to correctly affect the part. Remember, adjust the micrometer by half the amount the setup is in error. Before adjusting the tool micrometer, check the layout sheet to make sure of which tool controls the dimension you wish to correct. Run a few parts and continue to adjust the micrometer until a part meets specification. Knurl tool radial adjustments can be made after the knurl blank is the correct diameter. First, run the machine to high point of the knurl tool cam. Stop the machine. Adjust the knurl tool micrometer while holding the knurl tool counterbalance against the cone. Adjust the knurl tool micrometer until the knurl wheel just touches the part. Restart the machine. Run a few parts. Check the knurled portion of the part for proper dimension. Also check the part for the quality of the knurl. The knurl should be clean, cut with no mashed or stripped spots. A knurl tool adjusted too deep will strip the knurl off the part. To control a part diameter on some jobs, the tool cam number 2 positive stop may be used. This is usually specified on the layout sheet. Tool cam number 2 for this type of job is usually cut 2 to 4 thousandths lower than needed to cut the part. First, run the machine until tool cam number 2 is at low point. Push the hand wheel in to stop the main camshaft. Adjust the positive stop to contact the positive stop lever. Continue to turn the micrometer another 2 thousandths. Restart the main camshaft. Run the part and check the dimension on the part the positive stop was used to control. You can make fine adjustments while the machine is in operation. If the positive stop is not to be used on the job, make sure the positive stop is backed off far enough not to interfere with the normal operation of tool cam number 2. When running the parts, also check the ends of the finished parts for cut-off teats. Also check the end of the stock and the bushing for cut-off teats. Some parts may have cut-off teats on both the collet and bushing side of the part. This may be caused from a poorly centered tool or insufficient travel of the cutoff tool past the center of the part. The cutoff tool may also be in poor condition. The cutoff teat on the collet side of the part may be caused from a cutoff tool in poor condition, or the collet may need further centering to the stock guide bushing. A cutoff teat on the bushing side of the part can mean a cutoff tool in poor condition, or the stock guide bushing may have too much play. Some parts may also require chamfers to be formed on the part. The chamfers should be checked for the right width, angle, and eccentricity. An eccentric chamfer is one that is not the same width around the part. The width of a chamfer can be controlled by the tool radial adjustment and by the tool axial adjustment. An eccentric chamfer on the bushing side of the part may be caused by the stock guide bushing with too much play, or a guide bushing that is worn unevenly out of round. A chamfer may be eccentric on the collet side. This may be caused by the collet not gripping the part firmly, or an enlarged collet which will not allow the part to be gripped correctly. Incorrect collet centering will cause an eccentric chamfer as well. To check which way the centering correction should be made in relationship to the collet on the Model D2, feed the stock through the collet and out of the back of the collet. Mark the top of the stock that extends out of the collet with a knife or file. Run the part. Check the part on the end of the cut-off stock. Where the uneven chamfer shows up in respect to the mark on the top of the stock indicates which direction to move the collet. Move the collet in the same direction of the smaller chamfer using the mark on the top of the stock as a reference. The same check and adjustment can be done on the Model D4 by stopping the machine before cutoff and marking the top of the part in the tooling area. Then finish running the part. Move the collet in the direction of the smaller chamfer using the mark on the top of the part as a reference. Parts run on the Model D4 may also have to have drill hole dimensions checked and adjusted. Check the depth of the hole with the hole depth gauge. Drill depth is controlled by the drill micrometers. If, after adjusting the drill hole, the followers are extremely out of balance, reset the drill dimension from the face of the collet to compensate for the extreme adjustment of the cam follower. Then reset the cam follower tips to be even. Make sure after resetting the drill that the drill clears the tool area cover by at least 1 millimeter. Also check to make sure the contact roller clears the back of the spindles when the cam follower lever is fully returned. If the roller is not clear, damage may result when the machine indexes. Also check the drilled holes for correct position. If the holes are not within tolerance, the drill spindles should be recentered. To recenter the drill spindles, run the part and stop the machine before part cutoff. Mark the top of the part in the tooling area. Restart the machine. Check the part for the position of the off-center hole. Using the mark on the top of the part as a reference, adjust the drill spindle centering in the direction needed to correct the part. This completes your television training tape on controlling the quality of parts. You may watch this tape as many times as necessary to fully understand the material. When you have finished, return to the operator booklet for your next step.